All right, talking about 45, 45, 90 triangles. 45, 45, 90 triangles. People have known about the proportions in 45, 45, 90 triangles since ancient times. Because a 45, 45, 90 triangle is exactly 1/2 of a square. And in a square, all the sides are congruent and all the angles are 90-degree angles. 90, 90, 90. And when I cut the square along the diagonal, each corner that gets cut into two congruent 45-degree angles. All right. So to focus on the triangle that we just created, let's imagine that this square had a side length of 1 foot on each side. All right. And I've cut through this square, I've cut along the diagonal, and I've created a 45, 45, 90 triangle. All right. Let's call the hypotenuse x. I know that by the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. 1 squared is 1. 1 plus 1 is 2. If x squared is 2, then x equals the square root of 2. All right. So now, we've studied similar triangles. We know that any 45, 45, 90 triangle is similar to any other 45, 45, 90 triangle because of the angle-angle postulate. And we know that similar triangles have sides that are in the same proportions. So let's say I've got a 45, 45, 90 triangle where I know one of the two legs has a length of 3 units. All right. Well, I'm going to set up a proportion to find x. All right. 3 is across from the 45-degree angle. It corresponds to 1. 3 is to 1 as y is across from the 90-degree angle. Y is the hypotenuse. The square root of 2 is the hypotenuse. So y over the square root of 2. And I'm going to cross multiply. 1y equals 3 square root of 2. All right, now let's find x. All right, x is across from the 45-degree angle. So as is 1. So I'm going to say x is to 1 as, and now I'm going to take the 3. That's across from a 45-degree angle. So is the 1. I'm going to cross multiply. 1x equals 3. And I really didn't need to cross multiply here because we already know that if a triangle has two congruent angles, then the sides across from those angles are also congruent. So because this 3 is across from a 45-degree angle, and this 3 is across from a 45-degree angle, these two sides have to be congruent. Do I have to set up a proportion? No, I don't. If this is 0.6, and I know I have a 45 to 45, 90 triangle, the other leg is also 0.6, and the hypotenuse is 0.6 times the square root of 2. To make a long story short, if you know either of the two congruent short legs in a 45, 45, 90 triangle, to get the length of the hypotenuse, you multiply by the square root of 2. If you know the length of the hypotenuse and you want to get the lengths of the two congruent short legs, you divide by the square root of 2. All right. 45, 45, 90. 45, 45, 90. Let's say this is 8. Let's say this is 4. Well, I know the two legs are congruent. This is 4. To get the length of the hypotenuse, I'm going to multiply the leg by the square root of 2. In this second example, I know the hypotenuse. I want to get the length of the short leg, so I'm going to divide by the square root of 2. 8 divided by the square root of 2, and the other leg has to be congruent. All right, there's an issue of what's called rationalizing the denominator that we'll talk about another time, but these are the basics. Hope this helped.